Hey class, this is Mr. Roberts. It's a brand new year, and I'm going to be re-recording some of these homework solution sets. So we're starting today. I think it starts at question 38 and goes all the way to 42. So let's jump in and take a look at these. In question 38, we're supposed to determine the corresponding outputs for the given inputs of the following functions. And we are admonished if there is no solution, explain why or why not. Be careful in some cases. There may be no solution or more than one possible solution. So in this first one, I have here the 8 is going into this function. So when 8 is input into this function, right, this value picks up an 8. So it looks like this, the absolute value of 8. Well, the absolute value of 8 is 8, right? The absolute value of 8 is 8. So f of 8, so I would write f of 8 is the number 8. When I put 8 in, I get 8 out. That's A. Let's take a look at B. B says, ooh, we are going to take the number 3 and we're going to raise that to the second power and then add 1. So we're asked what f of 2 is. So 3 is raised to the second power. That's my x value, and then I add 1. Well, 3 squared is 9, plus 1 more is 10. So I would say that when 2, the number 2 is placed into this function, when 2 goes in, the number 10 comes out. Let's move over to, oops, this is K. It's part C. K is -6. So this value, -6, is going to go into the function. It's going to go into the function there. And when -6 goes into that function, this is going to become a -6 divided by 2, and I'm going to increase that 1. -6 divided by 2 is -3, plus 1 more is going to give me a -2. So I would say when f is -6, the output of that function is a -2. And then the final question is D. And D says we are going to place the number 3 into this function. So 3 is going to be the value that goes into it. When that happens, this becomes the square root of 3 minus 5. The square root of 3 minus 5 is the square root of -2. And we've seen this before. When I take the number, well, let's go ahead and grab the square root. If I take the square root and I place into that the number a negative and then a 2, it turns out the square root of -2, it's a domain error. There are no real numbers that have, there's no real results to that. So there is an imaginary result, and some of you are aware of that. More to come later with that. But for now, we would say that there is no real output. Okay, let's move on. Yeah, this next problem has an example, and then we're asked to find 2 other values. So the example they give us is they're saying, hey, here's this function. The function is f of x, and it equals 2 to the x. And it then shows us that if we were to place 4 into that function, right, this value x would be replaced with the 4. So this becomes 2 to the 4th power. 2 to the 4th power is a 2 times another 2 times another 2 times another 2. So there's 4 factors of 2 there, which gives me 16. So they're saying, okay, if that's what f of x is, tell me what f of 1 is. So if I take this same function, right, and I place a 1 in, it becomes 2 to the 1st power, which is simply the number 2. And then the other value says, okay, what about if you put a 3 in there? That becomes 2 to the 3rd power. We know that is 2 times 2 times 2, and 2 to the 3rd is the number 8. New year, if you want to see this, if you're trying to evaluate exponents on your calculator, there is a 2 and then go to the power of. So this is 2 to the power of 3. Enter. I will caution you, if you are taking a value, so like if I was to take, for example, -2 and ask the calculator to square that, to raise that to the second power, this is not -2 to the second power. This is the opposite of 2 squared, right? So I want to be careful. If the thing I'm intending to square is -2, I have to put that in parentheses. So that's -2. And when I square that, this is -2 times -2, which is +4. Oh, there is a part C. And in part C, it says, oh, what if you throw t into that? Well, that's interesting. So remember, the function is 2 to the x power, right? This function, f of x, is 2 to the x power. And it says, well, what if you put t into that function? Well, if I put a t into it, right, it becomes just 2 to the t power. So it's just I guess it's just swapping the variable out in this side. So whatever is the argument that's being passed in, right, that's the thing that shows up wherever x's are. This next question says a line is going through the point -3, -2, and it's going through the point 2, 1. Right? I'm told that it passes through those 2 points. And then I'm asked, does it also pass through the point 5, 3? So I'm going to think about this one purely graphically today. And let me just really quickly sketch an, I guess I'll just crudely sketch an XY axis. So here's an X, or here's a Y axis, and here is an X axis. And at -3, I'm down at 2. So this is that first point, right? If this is the origin, 0, 0, this is the point -3 and -2. So that's the first point. Then the next point I have is at 2, 1. So over here is the point where x is 2 and y is 1. And my question is 5, 3 also on the graph? So let's go. X is 1, 2, 3, 4, 5, and then up 1, 2, and 3. So when I draw that point, it looks close, but I don't think it's on that line. And we'll talk about it a couple ways. One of the things I could do is grab my ruler tool, and just even when I just line up the ruler there, you're like, okay, let's grab a nice red pen and draw it. See, it just looks like it's not quite hitting it, right? Other thing I could look at is like this slope pattern, right? So you can see up here, I'm going up 1, I'm going up 3, and then over 1, 2, 3, 4, 5. And if I did that again, I'd go up 1, 2, 3, and then over 1, 2, 3, 4, 5. So this point right here would be on it. But I believe this point is off ever so slightly. Ever so slightly. So that's just kind of thinking about it graphically today. We'll certainly be looking at more problems like that. But I think that I would have to say no, 5, 3 is not on that line. So when we see this icon in our textbook, the intent is that we put our calculators away and try to do this without a calculator. So let's honor that and see how far we can get. And we're just going to add some rational numbers here. So let's take a look at, oops, where's the first one? Here it is. So I'm supposed to add -1/2 and -1/5. Well, for me to combine those, I would need like terms. And I use this multiplying by 1 trick a lot. If I multiplied this fraction by 2, whoops, that's a sloppy, too sloppy of a pen for this. Let me clear that, grab this. I multiply this by a 2/2. What I'm doing is I know that I want this fraction to have a denominator that has a factor of 2 in it. And on the other fraction, I would multiply this one by 5/5. My thinking is because I'm just multiplying by the number 1, I'm not changing these fractions, I'm just changing their format. So when I do that one modification, this first fraction is going to become -5/10, which is clearly the same thing as -1/2. And then I'm going to be adding to that this number -2/10, -2/10. And when I do that, I should get -7/10. So the answer here is -7/10 when I combine those two. Now, I have the ability here, and my thing is I want to make sure I'm understanding this. So I might go ahead and grab my calculator and take, grab my calculator and take a look at it. So I can say, okay, I had a fraction that was -1/2. And then to that, I added another fraction. And this other fraction was a -1/5. And if I do that, you can see I do get -7/10. So, hey, I can do arithmetic. Let's move on and look at question, part B. Part B is way over here. Okay, so this one, I do not have a denominator on this fraction at all. So I'm going to take this number 2, which is 2/1, I'm going to give it a denominator of 3 by multiplying it by 3 over 3. So now this problem is going to become, right, this whole thing becomes a negative 2/3 minus 6 over 3. And you can see 6/3 is the same thing as negative 2. So this problem says the exact same thing. It's negative 2/3 minus 6/3. Negative 2/3, negative 2 and minus 6 is negative 8. So this is negative 8 over 3. And I don't know if they say, yeah, I'm really fond of improper fractions. So I would say just leave it like this. If you have to, you can write it. What is it? That's negative 2 and 6, so negative 2 and 2/3. But I'm really happy to see an answer that looks like that. All right, let's go over to C. Yeah, on C, I do not like C, and this is it. I don't like dealing with that because it confuses me. So I know 3 times negative 1 is negative 3 plus 2 is, this is negative 5/3, right? Negative 5/3 is the same thing as negative 1 and 2/3. So I'm going to rewrite this like this. And I know that I need 2/3, so I'm going to multiply this by, I'm doing a multiplication problem. It's not addition. So I'm just going to multiply that by negative 2, and I'll write it as negative 2 over 1. So when I'm multiplying these fractions, right, a negative 5 times a negative 2 is positive 10. And then the denominator 3 times 1 is 3. So this becomes 10/3. So when I multiply those, I get 10/3. And then the last part is D. Ooh, I have to do a division problem. So I've got this number negative 2, and I'll write it as negative 2 over 1. And a division problem, right, we can always turn a division problem into multiplication by the reciprocal. So I'm going to take negative 2 over 1, and I'm going to multiply that by 3 halves. Well, when I do that, it becomes negative 2 times 3 is in the top over 1 times 2 is a 2 in the denominator. So you can see there's a positive 2 over a positive 2. And the only thing I'm left with is a negative 3 in the numerator. So my answer should be negative 3. And I am feeling slightly insecure, so I'm going to clear my calculator. I want to check that. Oops. Check that. Let me clear this. So I'm going to just go ahead and take the number negative 2, and I'm going to divide it by the fraction 2 over 3. And I believe I should get negative 3 as my answer. And I do. Excellent. Final question here is a reminder that in previous courses, we learned about angle relationships when parallel lines are cut by a transversal. Those are all reviewed in today's math notes box in this lesson. So you might remember that in lesson 1.2.1, you can review about angle relationships when parallel lines are cut by a transversal. Just real quickly from my mind, I know that if 2 parallel lines are cut by a transversal, I know that opposite interior angles are congruent. So this angle and this angle qualify as opposite or alternate interior angles. So I would know that angle B, the measure of angle B, would equal 123 degrees. Another thing that I see here is that these two angles, I'll mark this one in green and the other one is in red. Those are adjacent, or they are adjacent, but they form a linear pair. So those two angles have to add up to 180 degrees. So if I take my calculator and take 180 and subtract from that 123, I get that this angle C, and I'll write this, but the angle C, the measure of angle C would have to be 57 degrees, because these two angles have to add up to a straight line. They're 180 degrees together. And then the last one I know is that these angles, angle B and A, are vertical angles. They're right across from each other when those two lines hit. So I know that A and B have to be the same. And because I know the measure of angle B, I can also write down the measure of angle A must also be 123 degrees. Let's move on to this next one here. Similar things happening. These two angles, I'll mark this one in green and I'll mark this one in red. They clearly have to add up to 180. So I'll take 180 and subtract from it 82. Yes, I'm literally using my calculator off screen. I'm ashamed. I get 98. So angle F has to be 98 degrees. That's the measure of angle F. E would have to be the same because these are parallel lines. This is the transversal. So I would say that measure angle E, is also 98 degrees. And then I would say that D is also 98 degrees. So I've got all three of those angles, right? Yeah, they're really all 98. They are. They are. They're all D, E, and F are all 98 degrees. And then the last question is this one. I'm given this angle. I'll mark it here in red. Red. Well, this is a alternate interior angle, so I know that G must be 75 degrees. And because G and H are vertical angles, they're right across from each other, H must also be 75 degrees. So for this problem, G was 75 and H was 75. That's it. About 15 minutes. That is the homework for this lesson. Thanks. Talk to you again soon.